Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Convolutional Neural Networks. CNNs. How AI sees the world like a detective, spotting patterns in images. Just like a detective looks for clues. Imagine you show a computer a picture of a cat. You see a fluffy feline. But the computer just sees a giant grid of numbers. How do we teach it to see and understand what's in an image? That's where convolutional neural networks, or CNNs, come in. Think of them as the expert detectives of the AI world, specially trained to sniff out clues and patterns in these number grids to identify objects, faces, and scenes. For a developer, understanding CNNs unlocks the power to build applications that truly see the world. Before our detective can start, we need to understand the evidence. To a computer, an image isn't a picture, it's a massive array of numbers. Each tiny dot, pixel, in the image is represented by a number indicating its color and brightness. For example, a black and white image might be a single grid of numbers, while a color image, like an RGB image, is actually 3 stacked grids, one for red, one for green, and one for blue. These grids of numbers are the raw data. The pixels our AI detective has to work with. This is the core of how a CNN works. Imagine our detective has a special magnifying glass, a small grid of numbers called a filter or kernel. This filter slides across our image's number grid, performing simple multiplication and addition at each step. Each filter is designed to detect a specific type of clue or feature, like sharp edges, corners, or specific textures. The output of this process is a feature map, essentially. A map showing where that specific clue was found in the image. As a developer, you don't design these filters. The CNN learns the best filters during training to detect important features. After the convolutional layer has found many clues, features, we often have a lot of detailed information. The pooling layer steps in like a detective summarizing their notes. It takes a small region of the feature map and reduces it to a single, most important value, e.g., max pooling takes the largest number in that region. This helps to 1. Make the model more robust to small shifts or distortions in the image, and 2. Significantly reduce the amount of data, making the network faster and more efficient to process. It's about keeping the most crucial information and discarding redundant details. A single convolutional and pooling layer can find simple clues like edges. But to identify complex objects, we need more. CNNs achieve this by stacking multiple layers. Early layers might learn to detect very basic features, like horizontal or vertical lines. The next layers combine these simple features to detect more complex ones, like curves, corners, or even parts of an eye. Even deeper layers combine those to recognize even more abstract concepts, like an entire face or a car wheel. It's like building a hierarchy of understanding, from simple strokes to complete objects. Once our stacked convolutional and pooling layers have extracted all the important, high-level features from the image, e.g., I found 2 eyes, a nose, and whiskers, single quote, this information needs to be put together to make a final decision. This is where the fully connected layers come in. These layers act like the detective's final deliberation room. Every input from the previous layers, the high-level features, is connected to every neuron in this layer, allowing the network to weigh all the evidence and make a final classification. This is a cat, or this is a dog, single quote dot. How does our AI detective get so good at spotting clues and making accurate decisions? Through training, we show the CNN millions of images, each with a label. E.g., this image contains a cat. The network initially makes guesses, and we tell it if it was right or wrong. Based on its errors, it adjusts the numbers in its filters, magnifying glasses, and the connections in its fully connected layers. This process, called optimization, slowly but surely teaches the network to find the patterns that consistently lead to correct predictions, making it a highly skilled image detective over time. CNNs aren't just academic concepts. They are the backbone of almost every visual AI application you encounter daily. Think facial recognition on your phone, object detection in self-driving cars, medical image analysis for disease detection, or even the visual search features in your favorite apps. As a developer, understanding CNNs allows you to leverage powerful libraries like TensorFlow or PyTorch to build, train, and deploy these models. You can create intelligent applications that see and understand images, opening up a vast new frontier for your projects and innovations. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.